software safer choice, right? And those are some questions that I would also like to look into in addition to some of the technical details. Most of the technical details have already been covered in the morning and will be covered after my presentation, so let's look at that. So, enterprise data storage challenges. If you look at the traditional legacy systems, right? Well, so here are all the pros of those systems. It's very hard to make a single traditional system scale up to the levels that Ceph can reach, right? You can put only so much storage behind a single three-letter appliance, whatever, network storage appliance, whatever the random may be, had, and there's only so much data you can fit in there. And one thing that makes me really jealous are the margins they get. The margins are wonderful if you're a customer. They're unfortunately quite expensive, and they're kind of hard to integrate to a scale-out data center, right? So it's not easy to use these for the modern applications. Some of them try, and some of them are successful. But overall, open source has this tendency to, just run over it like a steamroller. And also data tends to grow very fast, right? Hard drives grow fast. It's incredible how much storage you can now fit into a single 3.5-inch drive. But all that data growth is going even faster, so you just can't put it into a single system, right? We've already heard about the Internet of Things, transactional data, emails, medical data. Medical data sometimes has to be kept around for 10 years after the person's dead, right? So a lifetime plus. It's not just 7 years, 10 years. 10 years for the lifetime and beyond. And also when you look at things like machine learning, your source code is your training set, right? So, and the training set for training an autonomous car is the telemetry gathered from everywhere. And you have to be able to run this through your training algorithm again. So you have a lot of data that you eventually need to access. So there's a lot of data out there, that's basically the summary. And there's a bunch of data protection issues that people need to address. Data governance, all those problems. I won't go into these details too much. But that makes it also hard. Sometimes it can be hard to give those kinds of guarantees if you can't inspect the source code, right? What is the software actually doing? How do you fix that? So basically my summary about proprietary software, I've been doing this for a long time, single vendor ecosystem cannot possibly outcompete an open source community, right? There's just, look, we've started with presentations from Red Hat, now there's SUSE, there's Canonical contributing, there's Intel, there's folks at CERN putting rather smarter people than me on the project as well, right? So there's all these folks from the community that are contributing to this piece of software. And whenever somebody tells me, doesn't proprietary software have this edge or this feature, and that may be true for a while, but it's impossible to keep up with this level of distributed effort, right? Nobody really deploys large-scale proprietary Unix environments anymore, right? Linux has one, it's just gone. My smartphone, Linux may never happen on the common desktop, but my smartphone runs Linux, right? The proprietary software is a dead end. So it's destined to be a niche player in the long term. And Ceph, for people who care about this, they have all those analysts and industry prophets that do compile those Gartner Magic Quadrants. And just there was this announcement about this proprietary vendor touting that they've been selected the winner there again, and how Ceph wasn't the winner. But look at that again. Ceph is on that twice. No other product is on that twice, right? So vendor login, if you want to go for vendor login, go with the winner, right? It's your only choice. But yeah, so it's really the writing on the wall is very clear, right? Ceph has taken its time, but certainly on the winning track. So all the things that you're already aware of, so Ceph helps you overcome these, right? It drives costs down because unfortunately we can't justify to keep the same margins. that those proprietary vendors do, because you could unfortunately buy our software from someone else. Salespeople in the room are now freaking out that I said that. I'm an engineer, I'm allowed. But over the end, it's for the technical solutions, this is a good thing, right? It helps with the competition, and in the back end, the engineers collaborate, so it's all good. No forklift upgrade. Sometimes when you go from one proprietary system to the next size, you have to do very massive data migrations. There's a lot of, you can't just keep adding to this. It's a Ceph cluster, you can just keep growing the capacity, in fact. And so there are a bunch of efforts that really help here. So, okay, the echo is a little tricky. So, SUSE Enterprise Storage, right? So we've heard about Ceph. What is this? What is SUSE even doing with Ceph? Do you have Ceph? Is it new? No, it's not, right? So if you look back at the history, I looked at my email archive, and the first time we had internal discussions about Ceph was at SUSE actually in 2010 or something, so it's been a while. And we shipped it for the first time in August 2012. So that's where those 5 years come from. It's over 5 years now. That was admittedly a technology preview, but based on Argonaut, so a long, long time ago in a galaxy far away. And that was basically included as our SUSE cloud offering with OpenStack. And then we added it officially. It became supported for that use case in Q2 2014. And then we eventually made a switch. We broke it out as an independent product because it made sense to give it prominence beyond just the OpenStack use cases. And then you can see that we finally settled on a marketing name. So we finally won there, and we've been tracking the upstream releases fairly soon. Sometimes there have been other releases due to changes in the base platform, but we've been tracking upstream fairly well. And then in 2016, we acquired OpenAttic, and the team has joined us and will present in more detail about their work after this this session, so that's great. And our most recent release is obviously SUSE Enterprise Storage 5 based on Luminous. So October 2017, and then we're obviously already planning the Mimic release, or the productization of the Mimic release for sometime this year, 2018. I know when, but I'm not allowed to tell you. So, not yet. So, what value do we or another of the Ceph vendors, Ceph supporters in the field actually bring to the table? We help you actually understand which of the open source projects are useful, right? Because Ceph itself is one thing, and by now it's fairly clear that Ceph is one. But if you look at the wider ecosystem, orchestration, the various library dependencies that Ceph includes that you have to keep updated, all those things, management UIs, deployment, configuration, there's really a lot. It's similar to if any one of you has ever tried building OpenStack from scratch. Yes, you could do that. You could build your own OpenStack distribution. And similarly, you could run your own Ceph distribution. You could build it all up, but maybe you don't want to, right? And it's not just the server, it's sometimes also the client. You have to make sure that all your clients are interoperable and fully compatible with your latest Ceph servers. So there's some value that we do bring to the table. And also, we incorporate patches, backports, obviously we do upstream work, and we also help our customers understand which of those features are safe, right? And that assessment in a business environment is not always quite the same as a community, right? So if you ask Sage's announcement for Ceph Jewel was, the Cephfs is now beautiful and stable, and production ready, right? And literally half an hour after that announcement went out, I had the first customers ring us up and go, can we use this now? And we were like, maybe wait a little. We have, use cases where you can, but maybe not for your home directories just yet. So all those things, right? There's a lot of advice and discussion that also consultants. So we do a bunch of consulting, is what I'm saying, right? And we also represent customers and partners in the community because not every company has the bandwidth to interact with the upstream community. Right? If you're a cert, right, you have PhD students that are free work, right? If you have free workers, sure, right, this is wonderful. sometimes it helps to channel this a little bit and not be overwhelmed with that community. And sometimes you have things where you have to interact with hardware vendors and software vendors for getting your application certified or things like that. So, and also sometimes your system, it's software, it goes wrong, and sometimes you need somebody to drop whatever they're doing and you have to work on that. And that, support on their mailing lists for Ceph are awesome, right? The Ceph IRC channels are all awesome. But he who pays the piper calls the tune, right? If a customer calls us, we have to unfortunately stop developing the next feature and fix the one we already shipped. Sometimes that's a valid trade-off from a customer point of view. And we've had support cases. I have one that's burned to my brain where we had to deal with firmware that was happening only in combination with that network card, that Linux kernel, and that network switch. And that was not fun. Ceph didn't lose any data, but a kernel that's panicking every 30 seconds, or network infrastructure that decides that 300 kilobit per second is really enough between two nodes is not a happy environment. So there was a lot of fun, and I would not wish that on the customer unaided. And that customer actually now turned into a success story, right? They were so happy with after we solved the problem. They were so happy about the level of support they received that they now turned into a success story in their public, but I'm still not going to tell you which one now. And sometimes the community response to, can you just upgrade is not possible if you have a large environment. So there we go. So much for the advertising. What else is going on in the Ceph ecosystem? So there's a Ceph advisory board which I'm including here because there's some misconceptions. There's very little technical discussions going on there. It's mainly some coordination around major events like Ceph Days between some of the major stakeholders in the Ceph ecosystem. And that list is probably going to eventually change, but just as a shout out for some folks from Canonical are here, CERN, Fujitsu, Intel, Red Hat, obviously, SanDisk, SUSE, and Vito represents the Ceph user community there. It's just basically, frankly speaking, it's a talking shop. If you want to get involved with the technical details, join the CDM. But this is still sometimes tries to do important work and just justifies its existence. So again, there's no technical cabal that sets the direction. The direction gets set by the people who actually do the code, right? That's the way how open source communities work. Or the people who pay the people who do the code, right? So there's always a difference. I've already mentioned that we have a product out there that's not so interesting. You've seen that slide. There's just a tiny difference here that I would like to highlight. So in addition to the core Ceph deployments that we have, so with the monitor nodes that you have and the storage nodes, we also introduced the concept of a management node where we run our orchestration framework, right? So that's where DeepC, Openmatic, Prometheus, so our salt-based orchestration, our management and monitoring functionality runs on by default. So that's normally not a cluster member. That node could even be virtualized, depending on the performance needs you have. But so we add one node so we can orchestrate the running cluster. Because trying to orchestrate the node you're running on is technically possible, but it gets, get into all sorts of bootstrap issues. So this is really quite useful, and we are working on integrating this and making it highly available and adding redundancy and scaling that out. We'll talk about that in a second. So with SES4, for example, so the previous release that was based on Joule, so our major releases are primarily tracking those major Ceph releases, obviously. And let me just say that the 9-month release cycle is really not that fun if you're trying to push out a release once per year, but that's a discussion for another time. So that was already, it basically takes the Ceph product and project and turns it into a commercial product, right? Other vendors have similar offerings, and we mainly, the technology is pretty similar, but we sometimes differ in the level of support for various features, and sometimes someone has grabbed the dot release that's one dot release ahead, or backported something, things like that, but in general, the core functionality is the same, and that's by intent, because otherwise we would be reintroducing the vendor lock-in that we don't want, right? That's a it's something that we in engineering couldn't maintain. If we wanted to keep vendor login and keep technology differentiation, we would have to do all the things proprietary vendors have to do. And we rather want to benefit from the participation of the community. Right. But for example, in that version, we finally rolled out the early access for NFS Ganesha for the Ceph re-export, and that's an ongoing struggle. And I have some points about that. And we basically provided the first version of Ceph support for large files. So not small files, not very metadata intensive, because in Joule, the multi-metadata server support and partitioning that didn't work so well yet. Let's leave it at that. And so that's something that we then introduced in version 5 with Luminous. So we picked up the most recent release and looked at the roadmap and the various use cases and decided, okay, now more functionality works, right? So that's the kind of guidance that we can provide here, and we'll get into that in a little bit. Also, erasure coding, all those things that we've already heard of. One of the biggest things that we added is obviously the Prometheus Grafana dashboards. We'll see more about that in the next talk, I'm pretty sure. And also some questions that already arose in the morning. So, no, Ceph currently cannot easily convert between FileStore and BlueStore, but our orchestration layer can, right? So, as part of the orchestration layer, because we know which nodes are running what, you can re-roll with a different profile and say, I now want to convert these OSDs from FileStore to BlueStore. We'll evacuate the old ones. Once there's no data, they get redeployed with a different layout, with different devices. And at that point, we redeploy and the data starts migrating back. And then the node is upgraded and we take the next one. Now, to be fair, this is a long-term process. Because in this way, because there's no loss redundancy ever, we essentially have to rewrite every data twice, right? So we first evacuate it, which means we write every replica to another node, and then eventually that node gets redeployed, and then eventually that means the data has to be written there again. So don't expect this to be fast, but Ceph still makes it possible to do this while the cluster is running, right? So we are completely changing the on-disk format, and it's still working. You know, the clients continue to access this. Depending on how much bandwidth you've allocated, it might slow the access down, but it still remains accessible. So that's fairly impressive. And also for upgrading, we have familiar orchestration. We can, upgrade the nodes one by one, because we have to do it like this, because we are not yet running on Kubernetes. I have some more look for that. But so upgrading the nodes one by one in the right order, that's also important. And we also have with that rolling out updates, right? Your Ceph cluster has to constantly get updates. Also, we can import now clusters that weren't deployed with our orchestration, say via Ceph deploy, and put those under control of our orchestration framework after some tweaks. So, these kind of things. That's obviously it's all open source work, but it's still it's not as exciting as working on the crush algorithm, but it still needs doing, right? If you actually want to deploy this into production. I'm not going to spend too much time on these slides because we have a dedicated Openmatic talk. But so dashboarding, just some screenshots. I will leave that to the next presentation simply because we have a dedicated point. And then, for example, again, for some of you this matters, storage partners. Some customers want to run Veritas backups, and they want to back up with Veritas to a Ceph cluster. And sometimes those vendors have this need to certify. No community project usually wants to do that. You have to find a corporate sponsor to do the certification, right? Which is our way of making sure that somebody actually buys our product. And so there's a lot of interaction there that's really, frankly, very, very boring. The community probably hates working with certification toolkits. It's really not fun, but it still needs to be done, right? So that you get the checkbox that you can actually use this in your enterprise environment, that you're not liable for anything, that you can say you're compliant, all those things. Other use cases, obviously the biggest use case we still have is OpenStack, right? Storage for OpenStack is the biggest use case still, because it's a perfect Mode 2 application. I suspect we'll also see this with container as a service platforms. So a lot of that, there's some work with SAP and HANA as well. We see the first use cases in the high performance computing frameworks, where it's mainly used as an archive or for data that doesn't have to be read or rewritten that fast. So there's a lot there going on hardware certifications, reference architectures. And those are really important because, when you're a customer and you go, I want to build a Ceph cluster. And the answer is, sure, go buy some hardware and run your cluster. And you go, what hardware? And then the development community comes back, well, what do you want to do? And most customers can't really describe the workload very well, right? So having some reference architectures that say, start here, this is what you can use. And then tune as you better understand what your particular workload actually does. It's really important because otherwise you're standing there, everything is possible and you really have no way where to start. That's probably pretty hard to read on the projector. So file system use cases, we have a bunch of them now. Our primary use cases are backup, archiving, analytics, and some commercial HPC environments. Home directories are still a little bit out there because it depends on the access patterns. If you have lots of small files with lots of metadata operations, that might still take a little. Object storage is obviously perfect for Ceph. Those are currently our largest deployments, our object storage. I will talk about how big our growth is in 2 slides from now, maybe 3. That's mainly archiving, again, backup, but also cloud storage, video streams, archiving for medical images, all those things. We have a lot of those scale really well with Ceph. And log, of course, that's a very prominent use case again, also with VMs and OpenStack. And in theory also with connections via iSCSI to other legacy systems. But I have words on iSCSI gateways in a second. And actually, if you look at this, it's kind of funny. If you look at the original announcements from when was this, 2004, Ceph was originally meant to be a distributed file system, right? That's how it got started, and that's actually the part that finished last, because it turns out distributed consistent file systems are really hard. Block storage and object are way easier because of guarantees. And also with file systems, the biggest limit to being able to scale is the need for consistency. We could scale so well if we didn't have to be consistent, right? So strong consistency is really one of the big obstacles. Let's look a bit at this is forward-looking statements, subject to change, no commitment to deliver, the board is going to put that in. Where do we want to go from here, right? So what's the next thing? So obviously Mimic. I'm not going to repeat everything we've heard about Mimic. But what does this mean? So we are also going to rebase on the next version of the Linux kernel onto. Internationalization and localization has turned out to be really important. We are seeing a lot of adoption outside the English-speaking world. It's a strange thing that some of those characters looks really quite different, and the administrators want to be able to interact in their local language, right? So that turns out to be work that needs doing. Then we have Ceph Manager and the automatic conversions for management, so that we can get this back into the community track, which is really important to us. And where again, that's probably bulk of the next presentation as well, all the automatic things. But also improving scale-out management, monitoring, and deployment. We are seeing that, having a dashboard which tries to show one graph per OSD really doesn't work so well if you have 10,000 OSDs, right? Well, the server is fine, the browser crashes, right? So, all those things where you have to make sure that the UI actually scales. And UI is one of those things that open source communities are traditionally not very good at. So that normally needs somebody to work with that. Integration with eventing and alerting, which we also want to base on Prometheus and integrate nicely. Improved metric reporting. We have this thing that people want sizing, and we have the big proprietary winners have one thing going. It's controlled ecosystems where they can get a lot of data from their customers in a standardized format. And we really would like some similar data. So this Vito has some work on that. Maybe we can talk about that. Also, continuing to integrate with those NFS Ganesha, SIFs, Samba deployments, because unfortunately NFS and SIFs are around, right? They're not going away. And of course, we love Kubernetes, and that's also on the roadmap where folks at SUSE are also looking at, and where we also will have a presentation on Kubernetes manager in detail. So I'm not going to go into too much detail now. But let's look a little bit, taking a step back from the product. How do we see Ceph deployments grow, right? I tried to break it down a little into 3 phases, which are obviously probably there's a phase 4 or something in between. But so when we started out, when we had the first deployments in 2012. Those were all non-production lab environments, right? Somebody wanted to play with this, the technology was cool. The customer had a pretty good understanding at the time what they wanted to do because they were very involved in the technology already, and they just wanted, somebody to sign off that they got it somewhere officially. And then in phase 2, which probably I would say goes until 2015, 2016, we saw small deployments. And with small deployments, I meant customers running clusters of, say, 4 to 7 nodes, right, where Ceph really has a hard time showing off well all of its features. But those were like replacements for traditional storage arrays, right? That's what they were used to this. They wanted, 4 nodes that provide iSCSI to VMware, and that's what they had, and that's where they wanted to tie this in. And now we are finally seeing the kind of deployments that CERN has been running for all the time, but for the enterprise world tends to lag behind a little. What I call scale out, or Gartner calls this mode 2 deployments, where we are seeing 1 petabyte per month predicted growth, right? So at that point in time, making sure that you can actually cope with all the rebalancing traffic becomes a problem, right? And basically, as understanding and technology grows, so does adoption. And for me, the bottom line is this finally starts making sense, because in phase 2, I was like, this doesn't make sense, you should be buying a network attached storage box, right? If you're not planning to grow, if it's not a learning environment, if you know that you will be stuck on 4 nodes and just, put in bigger disks into those 4 nodes, then Ceph is a scale-out solution. It's not meant to scale up. With 4 nodes, you will lose out on many of the functionality of Ceph, right? Now, finally, advice nobody asked for, and I wish they did. What does this mean, right? Prepare for this new paradigm that you're going to scale out, not up, right? And do this before you order the hardware, right? If you think that you're going to scale by adding in 1 rack per month, you add 2 petabytes of storage per month, and because your average bandwidth is only going to be a few gigabit per second, so a 40 gigabit interconnect between the racks is really good enough, right? And it's not how Ceph quite works, with the rebalancing and backfilling and all those things. Also, don't pretend that you can put this in and never touch it again for the next 5 years, right? Ceph is still evolving, it's software, you have to plan to update and upgrade regularly. And we differentiate there with update, we mean apply patches to an existing system, minor kernel updates, but also upgrade when, say, the next version of Ceph comes out, right? When Mimix comes out, plan to be able to upgrade to this in some reasonable amount of time, which Ceph allows you to do. In general, it's been always getting better at this, and sometimes the sizing can be really hard, right? It's hard to predict how your system will perform for your particular workload. It's just really hard. So basically, the best thing you can do is run a pilot and tune as you go. Keep adding systems, keep changing. You will have to. You can start with a reference architecture, but be prepared that if you're going to build a 50 petabyte cluster, that the first rack is not going to be the hardware configuration you're going to finish this with, right? Prepare for the fact that there will be some tuning of your architecture. That's different from buying from a big proprietary vendor which says, well, this is our biggest box, go buy it, right? Because it might not be. This is the box that's as big as you want it to be. don't skimp on the networking layer. Ceph is a really distributed system. Don't make the network layer too cheap. Nowadays, I think nobody has an excuse for putting in less than 40 gigabit, and really you should be looking at 50 gigabit nowadays, because it's compared to the cost of the storage devices alone, it's really not that much of a difference anymore, and the latency really helps. One thing that sometimes upsets hardware vendors is that I recommend against buying all hardware from one vendor. This is in part related to this bug that I had to solve with our team. If all your network cards are identical and the bug is in the interaction between the switch and the network card and the network card's firmware, and your entire cluster experiences a kernel crash every 30 seconds, and all the network cards go offline at the same time, the cluster is gone, right? This is why heterogeneous environments are really a good idea, so that you don't have a single point of failure. Then your only single point of failure remains Ceph, which hopefully is better, at least we can fix it. So, make at least sure that your single point of failure is not proprietary software, right? If your single point of failure is something proprietary, nobody can help you fix it but that one vendor. So try to avoid that. Also understand the limitations of interfacing with legacy protocols. You've seen the comments that we can do iSCSI, we can do NFS, we can do Samba. But how Ceph distributes the data is basically it's a scale-out solution that randomly shoots the data to all the nodes in the cluster, right? And that's something that all the techies in the room understand. But then you interface this to iSCSI, which expects to go to that storage system, to that server via this one bottleneck, and then goes out. So you're essentially adding one network call, right? And that has implications on the maximum throughput and IOPS you can get. There's no way around this. Somebody told me to build a scale-out system that's good for iSCSI, I would not have designed Ceph, right? So you really want to look at a Ceph client that is actually capable of running a native protocol if you can, because that's when you get the maximum benefit. And again, you can scale bandwidth and capacity. That Ceph, you can get aggregate bandwidth out of any kind of hardware, right? You can just add more hardware and you get more bandwidth and more capacity. It's really that simple. But not latency, right? If your network layer is your, that hop here, and then over the cluster network, and then to the hard disk, before the write gets acknowledged, that's something that doesn't change. You scale out, but your network latency is the same, right? So that's something where you can only solve this by using faster devices and faster networking. And with faster networking here, not even 40 gigabit will help a lot, because that's 4 lanes of 10G, right? If you want lower latency, you need 25 gigabit, or 50, or 100. So those things matter. And again, consider the impact of growth and recovery. If you keep adding hardware, you have to scale the network so that you can actually cope with the rebalancing traffic. Or with the fact that you will constantly be backfilling. If you have 10,000 hard drives, 1 or 2 of them are always going to be broken and being replaced, right? It's just the nature of spinning media. Anything mechanical will break. So that's something that you have to figure into your benchmarks. Don't just benchmark them while the weather is good, right? Just try how the system performs in failure scenarios. So I'm almost done. I'm trying to finish a little bit early because Kai wanted more time. Proprietary software? No, let's just not go there. Right? That's about as clear advice as I would be willing to give. So Ceph in particular is really the bridge to the future, right? That's really the best bet and where the most momentum is, right? No other open source storage product has the momentum of Ceph. So basically the question is not if you will be deploying Ceph for your data center, it's really more like when, right? So that's really the message that I would like to go away with. And obviously, before we go to questions and answers, I have a slide that might be important. If you want to know more about Ceph, if the Ceph Day was not enough, there's a Ceph HoloCon planned for Asia Pacific region in Beijing on March 22nd and 23rd. So by my reckoning, you still have like 4 weeks to 3 weeks before getting the visa for Beijing will be tricky. Lufthansa right now is running a special promotion, so right now it's very easy to get to Beijing. The trip is really cheap. And it's going to be a great conference, 2 days, packed with technical talks and presentations. OpenStack summits also have good coverage of Ceph traditionally. So Vancouver will have one in May, and then in Berlin in November, I think. And the Linux Foundation Open Source Summit in Vancouver in August will also cover Ceph. So with that, maybe we have time for 1 or 2 questions before we find. Do you already want to come up?
No, I'm totally fine.
Okay, good. Okay, questions?